The broadcast is now starting. All attendees are in listen-only mode.
Welcome to the latest IChemE Safety Centre webinar. In this webinar, we're going to be talking about effectively removing mercury contamination in oil and gas exploration and production systems. As you'll be aware, mercury can be quite concerning when it's in our environment for human health, and we'll hear all about that today. If you have any questions throughout the presentation, please put them into the question box or the chat box. I'll be monitoring both of them, and we'll be able to address those questions at the end of the session. So without further ado, I will start by introducing our speaker for the day, Melanie Windust. So Melanie is a certified occupational hygienist with postgraduate qualifications in occupational hygiene and occupational health and safety. I've actually worked with Melanie over several years, and so I've witnessed firsthand her ability and professionalism and competence in this space. I'm not going to read through all of the details. I'm going to leave those for you to read through, but I'd just like to welcome Melanie and note that in the past, as it says in her bio here, she has received the Draeger Young Hygienist Award in 2010. So I'm sure you'll find we're in great hands with Melanie when she's talking to us about the hazards of mercury. Over to you, Melanie, and welcome.
Excellent. Thank you so much, Trish. That was a very nice introduction. I very much appreciate it. So today I will be talking about the effective removal of mercury contamination, but just first wanted to talk about the group that I'm working with at the moment is ADE Consulting. They're a wholly owned Australian organisation, consultancy, who specialise in environment, hygiene now, with people like me being brought in the last couple of years, geotechnical and emerging contaminants and treatment, remediation and research, really currently around PFAS, but that will broaden. Drilling, quite a few laboratory services, got a fantastic lab in Melbourne and in Sydney, which can do lots of different occupational hygiene, environment, testing, as well as PFAS. And we have offices in Queensland, New South Wales, Victoria and WA. So I'm the technical lead for occupational hygiene, and when I first started this company, one of the first conversations I had with the owner of ADE was around mercury, because it is one of my passions, and it's probably been one of my bugbears a little bit when I've been working in the oil and gas industry. So I was really excited to hear what and put in full disclosure, Earthcare Group is a chemical development and manufacturing company that the boss of ADE also has some joint shares and is on the board. So we work very closely with Earthcare Group as a manufacturer of chemicals that do remove contaminants like mercury. So, mercury is a naturally occurring trace constituents of coal, crude oil, natural gas condensate, and virtually all geological hydrocarbons contain measurable quantities of mercury. That obviously differs in different parts of the world, and different crude oils, for instance, have very, very different mercury contents. I think my first role as a process chemist at ExxonMobil down at the Longford plant wasn't a huge amount of mercury. I think the most mercury that we come across is broken thermometers at the time. But mercury is a liquid at room temperature and pressure, but when it's heated, it vaporises really readily, and heated doesn't even have to be a huge amount of heat being put into a mercury liquid to form a vapour. But unlike other hazardous substances, especially in oil and gas, like hydrogen sulfide, aromatics, mercury vapour is actually colourless, odourless and tasteless. I think at higher concentrations of mercury vapour, you may get a metallic taste in the mouth, but this really can lead to a false sense of security for people who are entering into things like confined spaces, who don't actually smell the contaminant and don't know that it's there, or in some facilities, especially outside the oil and gas industry, where there may be a known risk, but it might not be known across all industries, like gold and paper milling, that mercury is there. And if you don't test for it, you may not know it's there, and you may not put controls in place. So mercury alloys, it alloys very easily with other metals such as steel and copper, which can cause significant process safety issues, especially with copper. But even with steel, it can degrade the life of the equipment, and really the maintenance programs with high mercury containing equipment needs to be taken into consideration. Mercury contamination, especially in the oil and gas industry, can be process mapped throughout the facility, and areas identified with the highest risk. Its boiling point and the vapour usually goes over your C5s and C6s in your overheads, although there can be trace amounts through the whole facility. The higher risk areas in those types of production systems really are in your ISOM and your LPG systems, because they do follow the slightly lighter ends of the processing. However, things like sulphur units, if you have sulphur units, you're very unlikely to find free mercury liquid or free mercury vapour, just due to the nature of the chemistry that it forms very readily into mercury sulphide, which is one of the most insoluble compounds known to man. And we actually use just pure sulphur to clean up mercury spills, for instance, because it's excellent at scavenging all that mercury up and really making it into a relatively benign substance as mercury sulphide. So if mercury contamination has occurred at any time in your facility or equipment, it's likely that the contamination will remain until it's decontaminated, because it forms alloys and it's a corrosive metal and it actually embeds itself into your equipment. I've seen examples where the mercury contamination was still present when there wasn't any, this was in LPG systems, and there wasn't any LPG that had mercury contamination in it for up to 10 years, yet those vessels were still quite contaminated with mercury over 10 years later and had caused quite significant exposure problems during maintenance activities. So having worked in the oil and gas industry on and off for 25 years, mercury has been an issue that I've struggled with, because not only does at times it can take days and days to prepare a vessel to allow somebody to enter safely. When they do enter, they may have considerable personal protection equipment on, and that leads to health and safety issues, as well as additional cost and lack of efficiency. There have been other controls utilised, like steaming of vessels, potassium iodide treatment that can cause other issues that are around the environment, as well as health and safety issues, and I'll talk a little bit about that in a minute. So the projects that I'm going to be talking about, I'm really excited when I first heard about them, because this would have made my life much, much easier in my last 10 years working in different refining sort of process areas. So the next one, is just to show how mercury does vaporise very easily. This first one is just in air, and you can't really see any vapour coming off mercury, but under a different light, you can see the mercury vapour in the purple there. And as I said, because you can't smell it, taste it, or see it in normal light, you can be in the illusion that the mercury vapour isn't actually present. So if you have a look at this particular table, it's really interesting that if you've had mercury vapour and you poured it into the palm of your hand, and your palm of your hand may be at about that 30 degrees, so you potentially could heat the mercury up to 30 degrees. The vapour concentration is quite exponential when it's heated, and in a fairly confined environment, this could go into immediately dangerous to life and health value very, very quickly as the mercury vapour takes over that particular confined space, for instance. So at moderate temperatures, it can cause a quite significant amount of vaporisation. But in oil and gas industry and in other manufacturing and different processing industry, you can generate mercury vapour that in any type of maintenance process that produces heat, or disturbs sludges or the surface of pavement equipment, especially in the confined space where it can accumulate rapidly. So steaming out vessels, you will get mercury vapour. Removal or disturbance of sludge, like vessels in direct sunlight. I found that being in Western Australia or even up in the northwest, where it's very hot in daylight, summertime especially. So in the afternoon, just the vessels, just by having direct sunlight on them, would be producing significant amounts of mercury vapour within a confined space. Any sort of surface preparation, like grinding or buffing, cutting, welding actually produce significant amounts of heat, and if there is embedded mercury within those structures, then it will come out straight into the breathing zone of the person who's doing that maintenance activity. So mercury has a number of different risks, not only from a health and safety perspective, but environmental as well. And these reduce the efficiencies of maintenance activities and considerably add to costs of turnarounds as well as any sort of demolition process, especially if you had to get rid of any sort of equipment as mercury contaminated waste. But mercury can absorb, as I said, and can be absorbed into carbon and stainless steel process equipment. And to understand the mass distribution and species along the corrosion profiles in process equipment is really critical to be able to successfully chemically decontaminate that speed chemistry, process plans and objectives. So one of the things I really like to talk about when I talk to people about mercury is states of matter, typical sources, and how you get it into your body. Because that's really what occupational hygiene is all about is, you know, what's the contaminant, what state is it in, how are you going to get it into your body, and once it's in your body, what's it going to do, and how's it going to have any sort of health effect. And I think with mercury, there's quite a bit of confusion. We talk about different exposure standards and immediately dangerous to life and health values, and really that's focusing on the mercury vapour. So as mercury itself, you can't breathe in the liquid. Ingestion's not likely, potentially absorbed through the skin, or if you have cracks or cuts in the skin, it could absorb. But it's when that mercury liquid it forms into mercury vapour that we can breathe it in. And because it's a vapour, it's a gas, it follows the gas exchange regions of the lung, it goes straight into the bloodstream, and it's small enough that it passes the brain barrier, can affect the central nervous system. And, you know, probably all familiar at some point, you've heard the stories that, you know, back in hundreds of years ago, hatters used to use felt to make their hat, and they used to apply mercury liquid into it, and they ended up with something called Mad Hatter's disease, which caused significant amounts of brain and central nervous system damage. So when we in OC hygiene we talk about exposure standards, we're really referring to the vapour, because that is the main risk of exposure and the main form of contamination that you'll find in any sort of processing. And it does happen to increase when you add heat or any sort of maintenance activity. However, when you go into vessels, especially in LPG where there may not be a lot of sludge, you can find some areas of quite contaminated dusts, and those dusts could be a mercury salt. So the mercury could be a mercury sulfide. It's normally mercury sulfide within, or mercury chloride, but mercury sulfide within the oil and gas industry, and as I said, highly insoluble. So when you're having a look at the concentrations, and it could be part per million concentrations, you can't then compare that to the vapour stage, because it's a different route of entry and it does different things in the body. So if you were to ingest or breathe in some mercury sulfide or mercury salt, it may not be small enough to get into the deep recesses of the lungs, and then the processes of the body would remove those from your lung. If they're large particles, it potentially could cough them up and they could go into the stomach, whether they get taken through the normal processes of elimination through urine and feces. Significant quantities of mercury salts could lead to some bladder problems, but really it's not a highly likely route of exposure or a significantly high risk. And the other one is organic mercury, and ironically, organic mercury isn't found in the oil and gas industry. It really is from contaminants that get into their water systems, for instance, and then go through some form of biological change through something like a fish, and that fish turns it into organic mercury, or methyl mercury. Methyl mercury can also be developed in the lab. It's probably the most highly toxic form of mercury that you can have, and it really can infiltrate into our biology very, very rapidly due to the fact that it is an organic mercury. So some of the chronic health effects for mercury: it's a corrosive gas and a cumulative poison. It generally has reversible side effects, but it can remain in the body for up to 50 days. Health effects can include from respiration or through your respiratory system, the tightness in the chest, difficulty breathing, fever, headaches, lung inflammation, and digestive disturbances, vomiting, etc. Chronic exposure creates central nervous system damage, kidney and liver damage, and symptoms of long duration exposure include personality changes. So it's going to get into the mad hatters disease and tremors, insomnia, fatigue, muscle weakness, and excessive salivation. Mercury vapour is hazardous, but it's not a known or suspected carcinogen at this stage, and inhalation is the primary route of exposure to elemental mercury and mercury vapour, with inhaled vapour has been most completely absorbed in the lungs. Elemental mercury is only slowly absorbed through the skin, but it does cause irritation to skin and eyes if exposure occurs. And in some areas where you are up around that, immediately dangerous to life and health value. If you are in working but below that, there is a need to protect your workers from that skin absorption. So some of the typical controls that we would use in the oil and gas industries to try first initially is to empty a vessel from all hydrocarbons and then start preparing that through an operational preparation from decontamination. It could be, it depends on the state of the vessel itself, that's steaming, purging, venting over a period of time. I've had situations where like an LPG tanker had taken 4 days of steaming before it was even safe for anyone to do any sort of maintenance activity in there. So it can be quite time consuming. And in that particular situation, they weren't introducing any new product that had mercury in it. So this was all very, very heritage contamination. So we're still dealing with that years after. So you potentially have personal monitoring. So prior to exposure or prior to a turnaround event, the maintenance operators in that area may require urine or blood testing so that they can then get tested afterwards. Just because mercury is found naturally in our eating and in our environment, you need to take a baseline prior. There's quite a lot of procedures when it comes to mercury, which can be very, very labour intensive, and the personal protective equipment can really cause issues, other safety issues. The TIChem overalls can cause heat issues because you need full TIChem overalls, boots. There is an A1E1 HGP3 filtering respirator for half face or full face, but often you really need to go to supplied air or carriage air breathing apparatus. Powered air purifying respirators don't have the facility to have that particular the mercury filter, so you can't use PAPR for mercury. Even cleanup, if you do find liquid mercury in any of your streams, the area needs to be barricaded off and needs cleanup crews to go into that, blocking off sewer boxes, deactivating sludge with salt powder. So it can get quite time consuming and obviously introduce hazards into your health and safety as well as your environment. So some of the types of things that have been done in the past, there has been a process in Thailand where potassium iodine has been used for about probably 10, 15 years to remove mercury from contaminated equipment. This process was developed about 50 years ago. And the advantage of the potassium iodine decontamination, it's old science, so it's well known, well established, and a lot of the clients are really familiar with the process and happy to go down that path. But there are disadvantages, generally poor results, up to only about 50% of the mercury is removed. KI is really expensive, but both iodine and mercury are volatile as well, so they can easily become airborne, which leads to further occupational exposure to these contaminants. Mercury and iodine need to be kept out of the soils and waterways, as they can cause long-term damage to the ecosystems for us, and they can enter the food chain. Symptoms of chronic poisoning of iodine are skin lesions and headache, allergic reactions, conjunctivitis, bronchitis and asthma. So proper ventilation, respirators and potentially self-contained breathing apparatus is recommended when working with iodine to protect the workers. So although it's a potential, potassium iodine can oxidise and mobilise mercury, it's just slow and inefficient. And as I spoke before about steam processes, it's really great for removing hydrocarbon material to get that LEL down so that you can enter into equipment. But it's pretty slow and ineffective for mercury. Oops, sorry about that. And it does create other waste and exposure risk to people around the vessel when you're doing that particular process. So what I'll be talking to you today is around about the EarthCare chemical decontamination process. So EarthCare completed really two important mercury mass loading chemical reduction projects. I'm sorry about that. In about 2014, 2015, that advanced the way they did their chemical and processing technologies. There's three main objectives to their chemical processing, and these were achieved in the initial 2014-15 projects. So they wanted to have enhanced chemical formulation with modified surface reacting agents effective in cold water, really that aim to be able to go into an offshore environment rather than bringing equipment offshore back to onshore, decontaminating and sending it back, is to be able to actually do that in situ. So to have that subsea pipeline application, and that was tested to 100% effectiveness in low temperatures, down to about 10 or as low as 10 degrees. The second thing they wanted to do was increase chemical contact time on simulated vertical surface. So FPSO cargo holds using existing infrastructure for chemical application, and they tested 97% and 99.7% effective in sequential applications. And the third thing they wanted to do was process a simulated spent chemistry. So the chemistry spiked at about 9,000 part per million mercury and about 1,000 part per million hydrocarbons, and they were able to treat that on site, in situ, even offshore, and they were able to treat that chemical back down to less than 1 part per billion residual dissolved mercury in that solution. So that chemical could then be recharged and used again, and just a small quantity of highly contaminated waste could then be disposed of, rather than disposing of significant amounts of liquid waste. So this meant for the hydrocarbon processing industry that this technology required the near total mercury mass removal from a process system, but really caught up with that need in technology. So the disposal, treatment and challenges posed by spent chemistry can now be effectively managed through discharge-ready processing, elimination of expensive waste streams that previously had few options for disposal. So just this one here is, but they've been, EarthCare Group have been involved in a substantial amount of trials, and currently are involved in quite a few trials for different offshore facilities, where they have been conducted on oil and gas processing equipment. The verification that we use in this, there's a number of different ways that you measure mercury. So we have portable XRS, where we're able to, in our lab, we've got the XRS where we're able to get tokens like this and have a look at the delineation and the amount of mercury within the process equipment, or we can take that to site and actually do those calculations in situ as well. So when you know the mass loading of mercury in your particular equipment, you can modify the chemistry to make sure that you've got the right concentrations and for different time intervals as well. So the analysis resulted were used to determine initial levels of contamination, then predetermined points in the system, and continuous analysis to monitor mercury saturation levels in the solution until that solution is spent. And once it was spent, it then can be recharged and the process can go again. So the samples of the contaminated metal were sent to laboratories for confirmation of decontamination, and as you can see with this one, that was had an average of 93.7% mercury removal. So the way that EarthCare Group have their response, and they are a chemical manufacturer as well as a research and development institution. They work hand in hand with other people like ADE, we can project manage, but they also work really, really well with contract resources, for instance, or other maintenance user organisations. So they don't generally work by themselves because they are unable to actually apply the chemicals. They're more of a producer and manufacturer and developer of the materials. But really, they'd like that bespoke approach where they can go into an organisation, know exactly what the problems are within that organisation, what the concentrations are, what the outcome that they want to achieve is, and then provide a solution that meets all of those expectations. So it's careful analysis of the surface to make sure that they have what the loading is of that particular vessel. They calculate mass loading. They create the precise chemistry. They have chemistry to also remove sludge and other barriers that will prevent the chemicals getting to the walls to get rid of the mercury. Then they have removal of the hydrocarbon, removal of the scale, and then removal of the mercury. And at the end, they get certification that the process has worked. And it's a really good way to actually have a really good indication of what the costs will be for a project. So this is one of my most exciting slides when I saw this. Contract Resources did a number of different processes and trials where they added the Earthcare Group's material. So this was one particular example, but there is a number of others. And as you can see, really, the first 16 hours of this particular one, where they're only just steaming, they're taking the overheads and doing analysis of mercury on the overheads. And at that point, it was above 10,000 micrograms per metres cubed, so it actually topped the equipment out, and they don't read more than 10,000 micrograms per metres cubed. So they did that for 16 hours, and then they added some of the Earthcare chemicals. There's probably over 30 or 40 different ones, but they added this particular one and waited until it was potentially spent. All of this time it was still, the overheads were reading above 10,000 micrograms per metres cubed. They emptied that out and did a rinse, and you can see at that 25, 26 hour mark, the rinse caused the mercury to go under that 10,000 micrograms per metres cubed. Then they did a second rinse, second mercury, Earthcare chemical wash, another rinse, and then progress that through. So they didn't actually get this to nothing, this particular project, because they really wanted to go in, do maintenance and get out, but they wanted to be able to do that maintenance safely and not going over the immediately dangerous to life and health, which is fantastic. Still had to wear PPE, but not SCBA, really only just basic level personal protective equipment of a half-face respirator with mercury filters and Tyvek overalls. So it increased the safety of the whole process as well. So there was two case studies that Earthcare Group did a number of years ago, and I'd like to discuss these with you now. One of them is the first one is the offshore decontamination of piping. And the second one's onshore decontamination, but of high value equipment to extend the life of the facility. So the removal chemicals are strong to extremely powerful mineral acid blends with controlled foaming, various corrosion inhibitors, wetting agents, oxidants, hydrogen sulfide scavengers, and hydrogen embrittlement inhibitors that allow controlled penetration and scale removal to metal substrates. Additional oxides can be added in the field on mercury mass distribution, species, and depth profile. Each formula has an AB version and can be modified based on mass removal criteria, hydrocarbon loading scale composition, metallurgy, and the depth profile. So in case study A, the project required performing a study to determine mercury mass loading, distribution, and speciation of various systems prior to chemical decontamination. Offshore in the semi-submersible drill ship and onshore well flow test process equipment. Based on this study, chemical decontamination plans, performance monitoring criteria, and spent chemistry material processing plans were all developed. And the key objective was near total mercury mass removal with an emphasis on not damaging primary steel alloy components. In case study B, the second case study, which was decontamination of high value equipment for reuse, well tests well flow test equipment and process systems on a semi-submersible drill ship were contaminated with mercury due to intermittent exposure to high mercury concentration hydrocarbon streams during the well flow test program. So the semi-submersible and associated well flow test equipment were scheduled for remobilisation to another field with lower mercury concentrations in gas and condensate. Mercury chemical decontamination was required primarily to prevent mercury from dissolving from interior steel processing system surfaces during well flow test operations and affecting mercury sampling and analysis data from the new production field. The project required performing a study to determine mercury mass loading, the distribution and speciation of various systems prior to chemical decontamination offshore on the semi-submersible drill ship and onshore well test process equipment. So similarly to case study A, the key objective was near total mercury mass removal with an emphasis on not damaging the primary steel alloy components. The mass loading per surface area is generally not homogeneous, with systems and equipment with varies of exposure, pressure, temperature of process, chemical composition, hydrocarbon streams and many other factors. What was needed was a versatility of the chemical's maximum loading potential for mercury and hydrocarbons. The chemical formula selected was based on the estimated mercury mass per surface area of the various systems required for decontamination. Chemical performance and maximum mercury uptake for these chemicals is well established, and solubility of mercury can be increased by up to over 100,000 parts per million. Offshore, on this semi-submersible, this meant the chemistry had a certain mass loading potential and was circulated in 4 piping runs of 4 hours each. The total calculated mass per surface area for offshore piping on the semi-submersible was approximately 4 grams per metre square, with a total mercury mass removal of 418 grams. So the results, this picture here depicts a 6-inch high-pressure flanges that we use to correlate the accuracy of XRF surface measurements using SEM, EDS and acid digestion. The top flange depicts a mercury surface concentration contour map pre-chemical treatment, and the bottom flange depicts the mercury surface concentration contour map post-chemical treatment. The overlying grid on each flange represents how the flange was processed into 1-inch steel. Coupons for SEM, EDS and acid digestion. Mercury mass reductions are likely higher than about 90 to 98% mass removal in much of the process unit systems decontaminated. But by using the highest mass loading per surface area equipment as a surrogate for the entire process, an ultra-conservative verification standard was established, and it meant it was able to remove about 10 grams per metre squared. One of the things that they've put together also is gel chemistry. So they've been able to concentrate their chemicals into a gel that can be applied. And I found this really interesting because certain equipment you may need to just go into and do some very, very spot welding or very, very spot maintenance. But you don't necessarily want to decontaminate the whole vessel because you'll be introducing mercury back into it when it gets into process. So you'd be able to go in and apply the the gel to it's usually about 1 metre or so either side of what you're working. It depends on what the heat profile of that particular vessel is, and then that gets scraped off and disposed of, and you'd be able to do your work, which is, I think that's really, really cool. I get excited about these sorts of things. So my conclusion is that, you know, with 98 to 100% mercury contamination removal, would the outcomes really benefit not only the environment and the people who are maintaining plant and equipment that was previously contaminated with mercury, but also really increases the efficiency and hopefully money outcome for stopping production or getting rid of waste that is contaminated with mercury. So this technology is also successful over a wide temperature range, transferable to other industries. So I have talked a lot, obviously, about oil and gas here, because that's where my background is. But there's other industries, like gold mining has quite considerable gold manufacturing, and paper milling also has significant amounts of mercury problems, as well as coal power stations. I love the fact that this can reduce the PPE requirements, which makes the process also more efficient, reduces risks of mercury exposures as well as heat stress and other safety risks that are introduced with significant amounts of PPE, especially when you're having carriage air breathing apparatus. So I'm not only passionate about working and to reduce workers' exposures to hazardous substances like mercury. I also consider myself hopefully an environmentalist, and I believe that we can all make a difference. And it's becoming increasingly important with progress away from oil and gas, leaving mercury contaminated sites that have been decommissioned. And it's in that sort of decommissioning that this sort of technology has the potential of making a really solid impact and not putting contaminated materials to landfill. So thank you very much for listening to me, and I hope you got something out of it, and I'm happy to take questions, and I'm happy to be contacted after the webinar for further information or anything that you would like to know around the case studies.
Thanks very much for that, Mel. A really interesting presentation, and I know that I certainly learnt some things about mercury throughout that I wasn't aware of, even though I've worked in some of these industries where mercury contamination is a problem. And one of the comments you mentioned was around how mercury attacks the copper as well as steel. And certainly I, having worked within the LPG sector previously, am acutely aware of how concerned we always were around mercury contamination within LPG. And it wasn't necessarily because we were worried about the tanks that they were stored in, but your standard barbecue cylinders, those sorts of things that you'll use around your home, various locations, all the valves are made of brass. They're made of brass for a reason in the LPG sector, but mercury can obviously then be a huge impact because copper is a component of brass, and so it can actually start to corrode your valves, which is quite a significant safety issue, as well as the occupational hygiene issue. And I think that's one of the key elements for me here as well. Whilst a lot of this is talking about the hygiene aspects of it, there are very real process safety implications to this. Do you have any information around issues you've seen with the mercury and its corrosivity towards some of the metals? So we've obviously got a concern around the way that it absorbs into the metal and then it can leach out and cause the human risk. But what about the corrosion to metals? Do you have any information on that you could share?
Interesting question. So I don't have any direct personal, except for, I've been involved in some like especially in ice bombs, and that seems to be a really big mercury sink, where completely cleaned out a vessel and completely gas-freed everything, let it stay for 6 to 8 hours, come back, and there's liquid mercury pooling again at the bottom of the vessel. So that's the amount that's actually coming out of the vessel just sitting there in, say, the hot sun. So, and that to me is quite terrifying, I suppose, but maybe from an occupational hygiene perspective. In a similar industry, or probably the same industry that we came from, within LPG, it was really interesting to see. You'd go into some vessels and they'd be quite clean, and even your mercury vapor completely got no readings, but as soon as you started having any sort of hot process on it, it would go above the immediately dangerous to life and health. And then some of those particular tankers which dealt with mercury kind of all the time, so constant over a 20-year period, you would go into them and we would be finding just actually non-describable sludge that it looked like something had melted in there. So we couldn't. We sent it away to a number of different places to see if we could identify what it was, and put it down to potential mercury influence on the actual structure itself. I know that there's been a lot of research, which I can't talk to, around the elongation of your plant and facility's life if you actually remove the mercury, because mercury will reduce the life of the facilities. So great question, but I probably can't give a huge amount of technical information on it.
No worries. So with the, it was really interesting as well, the application that you talked about being an offshore facility, decontaminating in that offshore space.
Mm-hmm.
There's obviously a whole range of different challenges in working in the offshore space, you know, not the least of which is getting resources to the platform, storing everything on the platform, and getting everything back off the platform again without creating any form of safety or indeed probably more likely environmental impact to it. What was the
Mm-hmm.
process that they were going through to make sure that that could be staged appropriately, so that they weren't having to remove enormous quantities of waste afterwards?
Yes, once again, excellent question. So what they did in this particular facility was bring in concentrated product. So they're able to actually make that up while on the offshore facility. And then they have this, it's a bit difficult to describe. They have a process where they're able to remove the mercury from the spent chemical, and I think it's around about 2 by 1 metre, so it's not huge, and it's a little processing facility where they can put the liquid in, the spent chemical, to remove the mercury. So that chemical can be recharged with more concentrated chemical as well. And so then I think I did mention, you just take off. I think they ended up, from the whole process, just took away just a couple of small containers of really, really highly contaminated mercury. But it wasn't like they were removing, thousands of litres of contaminated mercury product. So that was one of the ways that they introduced that. This particular chemical, when it's made up before it not concentrated, is actually it's not considered hazardous either. Mm-hmm. And it can go down wells. When it is in its concentrated form, you still need to have processes, which they have complete risk assessments and safe work method statements on how to do that. They generally like to supervise that. But once again, it's more of a corrosive than any sort of chronic long-term health effects that come from those chemicals. And so it's really about mobilising to site and being there as a project manager, and to make sure that those safety protocols, and working with the people like Contract Resources, who are very, very professional when it comes to health and safety, work really well hand in hand to make sure that it goes very well. In that particular project, there was not one health and safety incident of environmental as well. So that really ticked a lot of boxes, where it can be all in one. Especially, as I said, you don't have to bring equipment back in offshore.
Yeah, no, okay, thanks for that. It's particularly as we're starting to see more and more instances now with the decontamination and decommissioning required for offshore facilities. I think this is going to become more of an issue. Obviously, depending on how prevalent mercury is in the field. As you said, if it's Bass Strait crude, it's nice and sweet and not a lot of mercury, and never really had to worry much about that one. But certainly there are a whole lot of other crudes out there that do have very high mercury concentrations in them. I also noted on one of your slides as well that there's some experience with these chemicals also of removing the norms, which is another really important aspect. So, that's also very significant in terms of having to appropriately prove that you have decontaminated to the right standard equipment if you're looking to leave any of it in situ, let alone even if you bring it back onto land, you still have to dispose of that metal in some way, and the contamination can be an issue. Thank you so much. Go on.
Or even if you're sending equipment into another maintenance facility, like a contract maintenance facility, you have to make sure it's safe as well. And yeah, norm was quite a significant issue in the Longford and Bass Strait. So yeah, definitely those sorts of things would have to, the treatment that you'd have to go through to make it safe to exit site is significant. So
yep. Wonderful. Well, thank you so much, Melanie, for that presentation. I hope our audience enjoyed it and got a lot out of it. I certainly know I did. We have some more presentations, some more webinars coming up. If we just move to that last slide. So we've continued to try and endeavour to bring you webinars consistently over the last 12 months, as we did the previous 12 months, and we intend to continue to do this going forward. We have another 2 webinars coming up in the next 2 months as we head to the end of the year. The next one we have is on the 9th of November, and that is at 2 p.m. Greenwich Mean Time. That is a repeat of a webinar we did a few weeks ago on getting the best from remote HAZOP, and it's being repeated by popular request for a different time zone so that people can attend live and ask questions live. And then on the 10th of December at 9 a.m. Australian Eastern Summer Time, we have Manage Change, or It Will Manage You. And that is a presentation that will focus on some lessons learned from management of change incidents and what can happen when we don't get our management of change right, the sorts of incidents that we can see coming out of that. So please feel free to register for any of those webinars at our website. We hope to see you at them again in the future. Thank you once again, Melanie. Wonderful to have you on this webinar with us today.
Excellent. Thanks, Trish. Thanks, everyone.
Thank you, everybody. Stay safe. Bye.
Thanks, bye.